Here, let's go to page 280, and this is lesson 24.3. And this is infinite series, means the series goes on forever. So if you have 1 plus 1/2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus dot 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 dot. Okay, what does it equal to? Okay. Okay. The way to divide this actually is fairly easy. Infinite series is actually easier to divide. Okay. So what you do is you let S, so there's no subscript for infinite series, so equal to 1 plus 1/2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus dot 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 dot. Okay. So notice a common ratio is 1/2. So you want to multiply by the common ratio. So you multiply by 1/2. Okay. So 1/2 S equal to, okay, so 1/2 S, again you want to shift. So multiply this by 1/2, you get 1/2. Multiply this, you get 1 over 4. Again, and so shift. Okay, and then you're going to subtract. Okay, so use this minus this. So S minus 1/2 S will give you 1/2 S. And when you subtract, notice because it goes on forever, so all the terms will cancel out except for this one. And then you divide. So S equal to 1 divided by 1 over 2. So S equal to 2. Okay. So again, that's where they came from. Okay. So again, you're going to get, so from here, right? So you're going to get T1 divided by 1 minus R. So here's your T1 because everything got all canceled out. So if you notice, everything got canceled out. So only thing you have left is your T1. Okay. And that's where the T1 came from. And you divide by 1 minus R because what happened is this is 1 minus R, right? Because you have 1 S. You got 1/2 S. So you actually have these. Okay, that's what happened. 1 minus 1/2, and you divide. So this is actually 1 minus that. Okay, see that? Okay, so that's this over here. Okay, so 1 minus R came from this minus that, and you factored out the S. Okay, but anyway, so here's your formula. Okay, for the infinite series. Again, sum up what we have with all the different stuff. Okay, so first, you have to figure out if it's arithmetic or geometric. If it's arithmetic, then use these two formulas. Okay? If it's geometric, then use these two formulas. Okay? And again, this so you have one formula for sum, and you have another formula for figure out whatever you're missing. So when you deal with sum, you just go and write down the sum formula, and whatever variable you're missing, you use the other formula to figure it out, and you substitute into here. So same thing with geometric. Okay, so let's go and do the example. Let's go to example. Let's go to example 20. Let's see. Oh, that's another thing that I need to mention is the infinite series is convergent only if it's some tend to fixed value like this. Okay, so what happens? The absolute value of R had to be less than 1. Okay, in order to converge, or else the series is going to go on forever and it's not going to have a fixed value. So again, R had to, so it means the term had to get smaller and smaller and smaller. Okay, so like this one will not have. This one it does not diverge because the numbers gets bigger. Notice you get 1, 2, 3, 4, 5. So when a number gets bigger or the same, you will not have the infinite sum. The sum would just become infinite. Okay. So when this case is divergent, means it doesn't converge. Okay. And if the R is absolute value of R is less than or equal to 1, okay, so it means the numbers get smaller. Okay, like this case over here. Okay. So numbers get smaller, then it will converge into a sum. So that's just something to be aware of.